Hi class, today we're going to be talking about momentum and inelastic collisions.
In our example, we're going to use the case of the skateboard and the skateboarder. The skateboard with an initial momentum of 0 and the skateboarder with a much larger initial momentum.
This one's for you, Professor Anderson.
Go.
Alright, so in this first case, this is an example of an inelastic collision. The first mass we're going to indicate as the skater himself. The second mass we're going to indicate as the skateboard itself. So we know that momentum is always conserved, so that being said, sum of the momentums at the beginning equals sum of the momentums in the end. So m1 v1 is momentum 1, that's how we're going to denote momentum 1. m2 v2 is momentum 2, and that's all the initial. And the final, same goes. Mass times velocity, final of the skater himself and the skateboard itself. So in saying these two equal to each other, as up here going down to here, we know that the initial momentum of the skateboard is 0. So this all goes to 0 and cancels out, and we're just left with the first momentum, which is P1, equals sum of the momentums in the final. And because this is inelastic, both the skateboarder and the skateboard itself are pretty much stuck together, so they have the same velocity in the end. So that being said, we could reduce this down to just m1 v1 initial equals mass times velocity final plus mass times velocity final of the skateboard plus the skateboarder himself. And in further reducing it, we could just factor out the final velocity and just get. So in summary, we're left with the initial momentum, as we denote as P1 up there, is equal to the sum of the masses, the skateboard and the skateboard himself, times the final velocity.